Hello and welcome. In this tutorial, we're building a real-time facial expression panel using Upbge and a Vroid character. The strength of using Vroid is that it already comes with shape keys for facial expressions. We're going to learn how to control them using a gamepad in real time inside your game project. Let's start by setting up a visual panel that will allow us to edit expressions directly. First, create a plane and rotate it 90 degrees so it faces the camera when in expression editing mode. We'll give the panel a black material so the white text stands out clearly. To avoid any reflections, set the roughness value to 1.0. Now create a new collection called Expression Panel to hold all elements of the UI. Create a second collection named Expression Drivers. This will hold the objects that act as interactive sliders for each facial expression. Back in the panel, let's add a text object. Position and scale the text to fit neatly on the panel. Rename the text using Edit Mode, and then parent it to the panel using Control-P, selecting Keep Transform. This way, when we move the panel, the text follows. Make sure all the text objects are inside the Expression Panel collection. Next, duplicate the text object for each expression: angry, joy, sorrow, and surprised. Now let's create the driver buttons. Add a circle mesh, rotate it 90 degrees on the x-axis, enter Edit Mode, extrude it, scale it down, extrude again, and merge at center. We'll create 3 material slots: white, green, and red. Switch to Face Selection and assign different materials to parts of the mesh. Set roughness to 1.0 for each material to eliminate reflections. By default, all buttons will be red. When an expression is selected, the corresponding button turns green, so you know which expression you're editing. Name each driver accordingly, like dr_angry_0, dr_fun_1, and so on. Place all driver buttons inside the Expression Drivers collection. This is crucial because logic nodes will reference objects in collections by index. The first object will be index 0, the next one index 1, and so on. If your collection has 5 objects, their identifiers will go from 0 to 4. Select all panel objects and press Ctrl-A to apply rotation and scale. Note, you can't apply transform to text objects, so select only the panel and buttons when doing this. Let's configure the drivers. Select your Vroid mesh, go to Object Data Properties, and select the first shape key, like angry. Right-click on the value field and choose Add Driver. In the driver properties, select the corresponding object, for example, angry 0 as the source. Use y-axis rotation as the input and set space to local. To test, rotate the panel and make sure the local rotation works correctly. Keep in mind, drivers extrapolate up to 60 degrees. Beyond that, behavior becomes unstable. So, in our logic node setup, we'll clamp or cap values to stay below that limit. Repeat the process for each shape key and its driver button. Now let's move on to the logic nodes and create an expression selector. Select the panel object and add a new game property named emotion_select of type integer. Press the I key to enable debug display so you can watch the variable at runtime. Create a new logic node tree and name it something like Face Expression Editor. To modify object rotation, use the Set Local Orientation node. We'll convert degrees to radians using a multiply node. Reminder, the correct formula is degrees times 3.14 divided by 180. Since we only want to rotate on the y-axis, we use the combine XYZ node. Plug in our y rotation and leave x and z at 0. Repeat this setup for each driver object, just updating the target and condition. To choose which expression to modify, use the Get Object Property node to read the value of emotion select. Then compare it using a Math Compare node. If it matches the expected value, 0 for angry, 1 for fun, and so on, then allow rotation update. That way, only the selected expression's driver responds to input. We'll now create a map range node. This converts a float value from 0 to 1 into a rotation from 0 to 60 degrees. This lets us use analog input to control intensity. Back in the panel, we add 5 float properties, 1 for each expression. These will store the actual expression values and feed the drivers. Don't forget to enable the iDebug view to monitor them in real time. Let's handle gamepad inputs. To change the selected expression, use the D-pad up and down mapped to a tap node. Each press increments or decrements the emotion select variable. To adjust the intensity, use D-pad left and right, but this time use down key for a smooth analog feel. Each press will change the corresponding float value by 0.1. Let's add visual feedback. We use a Get Object property to read the emotion select and a math compare to check if the button's index matches. Use a logic branch node. If true, apply the green material. If false, apply the red material. Repeat this logic for each button. One final note. We need to create limits. For a motion select, we want to loop back to 0 if it exceeds 4, and clamp it to 4 if it drops below 0. For the float values, we want to clamp them between 0.0 and 1.0, so the shape keys stay within proper range. To make the system dynamic, we use the value switch list compare node. This node allows us to output a string property name based on the selected index. Case A, angry; case B, fun; case C, joy; case sorrow; case E, surprised. This lets us plug the selected variable name into any property node without duplication. And that's it. We now have a complete, fully interactive facial expression system driven by logic nodes and gamepad input, ready to use in any UBGE project. Thanks for watching.